Hey, welcome back. In example 2, we're finding coterminal angles in radians. And when we were working in degrees, to find a coterminal angle, we would add or subtract multiples of 360 because that was one revolution or rotation around the circle. Now that we're working in radians, we're going to add or subtract multiples of 2 pi instead. So in problem A, we want to find a positive and negative coterminal angle, and we want that to be closest to 0. So starting at 9 pi over 4, I want a common denominator, so I'm going to double my denominator here. 4 times 2 is 8. So one revolution would be 8 pi over 4. Since 9 pi over 4 is greater than 8 pi over 4, I'm going to subtract one revolution around the circle to find a positive coterminal angle closest to 0. So 9 pi over 4 minus 8 pi over 4 is 1 pi over 4. Then to find a negative coterminal angle to my given angle, subtracting one revolution was still positive, so now I'm going to subtract 2 revolutions to get the closest negative coterminal angle. So 2 times 8 pi over 4 in the clockwise direction means we're going to subtract. And that would be 9 pi over 4 minus 16 pi over 4, which is negative 7 pi over 4. Okay, in problem B, we're going to double the denominator. That's 12 pi over 6. And since my original angle is negative 11 pi over 6, I'm going to add one revolution around the circle to get to a positive coterminal angle. So I'm going counterclockwise since I'm adding. And negative 11 pi over 6 plus 12 pi over 6 is positive pi over 6. So there is my positive coterminal angle closest to 0 with respect to the given angle. Now, if adding one rotation got me a positive, then I would subtract one rotation to get a negative. So negative 11 pi over 6 minus, so now we're going clockwise, 12 pi over 6 is negative 23 pi over 6. And that would be my negative coterminal angle, closest to 0 with respect to the given angle. Okay, now in C and D, we're finding a coterminal angle over the interval 0 non-inclusive to 2 pi inclusive, which is one rotation from the initial side of the angle. So since we're starting here at negative 23 pi over 5, I double the denominator to get 10 pi over 5, but negative 23 plus 10 still isn't positive. It's not in that interval. If I do 2 rotations in the counterclockwise direction, that would be negative 23 plus 20, which still isn't positive. So I'm going to need to do 3 revolutions around the circle in the counterclockwise direction. So 3 times 10 pi over 5. That's 15 pi over 5, or sorry, 30 pi over 5, and negative 23 plus 30 is a positive 7 pi over 5, which is within our interval 0 to 2 pi. Okay, then in problem D, we double the denominator and get 4 pi over 2. So since that starting angle's terminal side is 13 pi over 2, subtracting 4 would not be close enough to 0. If we go 2 revolutions in the clockwise direction, that would be 13 minus 8. If we did 3 revolutions, that would be 13 minus 12. 4 revolutions would be 13 minus 16. That would be negative. So we're going to go 3 revolutions in the clockwise direction. So 3 times 4 pi over 2. And 13 minus 12 is 1 pi over 2, which is within the given interval. Okay, now in problem E, we want to find all of the coterminal angles for the given angle, and that's going to require this expression, theta plus or minus 2 pi k for k that is an element of the integers. Remember that that circle with a slash through the middle, that is the Greek letter theta. And when we're writing this expression, it's common practice that your theta should be a positive coterminal angle over the interval 0 to 2 pi. So when I look at my sketch, I can see that the given angle is a negative angle because the rotation from the initial side to the terminal side is clockwise. But I want to use in my expression a positive angle that's coterminal over the interval 0 to 2 pi. So rather than go ahead and find the negative and then add 2 pi to get positive, I'm just going to go ahead and start with my original angle, but going counterclockwise instead of clockwise. So if I start at the initial side and I rotate counterclockwise to the positive y-axis, that would be a quarter of the circle, or pi over 2. Then I go another pi over 6 units, that was given here in green, to reach my terminal side. So if I add those together, because I'm going counterclockwise, pi over 2 plus another pi over 6 in the counterclockwise direction, that needs a common denominator, so I'm going to multiply the first fraction by 3 over 3 to get 3 pi over 6 plus pi over 6, which is 4 pi over 6, and that reduces to 2 pi over 3. So the terminal side of this angle over the interval 0 to 2 pi is located at 2 pi over 3 radians. So the expression for all coterminal angles would be 2 pi over 3 plus or minus 2 pi times k for k values that are elements of the set of integers. Right, k has to be an integer. Remember, integers are positive and negative whole numbers, because k can't be a real number, right? If I didn't specify that k was an integer, we would assume k is a real number, and real numbers include fractions and decimals and irrational numbers, and those would not make full rotations around the circle. So we have to specify k is an integer to make it clear that we have to do full rotations around the circle.